In this wonderful little video, we're going to talk about how to calculate z-scores and see how different observations really are. Now, if you were given 10 numbers like this, okay, one of the ways you can see what's weird and what's not weird is just to select them. Well, you could select all of them, including the X, and say insert a line chart just to look at it, and that's what you'd see. Okay, and so if you're asking yourself which one of those is really different than the others, you'd see this one sticking out right here, which is point number 5 of a value of 238. Well, we'll use z-scores to that same idea. And for z-scores, you need to know a couple of things. You need to know the standard deviation, and you need to know the mean, the average. You can calculate these separately by saying equals STDEV standard deviation.s, STDEV.s, since this is a sample. So let's put that there. Select all of these and we'll get the standard deviation of all of them. And I am going to do something by hitting F4 on this PC, and you'll notice it puts in dollar signs in front of the A, the 2, the A, and the 11, so that when I copy this down, if I hit enter now, I copy it down, it will always refer to the same 10 cells. Therefore, it'll give me the same number in every one of them. Oh, that should have said mean. Okay, I'm do the same over here. Equals average of these numbers right here, and then I'm going to hit F4 and close parenthesis, enter, and I get the mean is 137.9. When I copy that down, it says 130, and you can check that by clicking on any one of those and click in the formula bar, and you'll see the blue here and the blue shaded here. That tells me what everything is referring to. Okay, now the formula for calculating the z-score, z-scores are calculated by, I was looking at the formula in your book. Yeah, there they are. So you can say that z is equal to the observation minus the average, x bar, all divided by the sample standard deviation. Sorry that didn't come out as clear as I'd like, but that's the formula. So we can come over here and we can calculate the z-score as equal to the x in this case will be the observation itself. So that would be that minus x bar is going to be right here, all divided by, oops, looks like I'm gonna need some parentheses here so that the order of operations is respected. That divided by the standard deviation of that. And having paid attention to references, I can now do that, and I can see what the z-scores are for all of these. Now those are probably a little bit too much information, we like to say, and when I shrink it down I quickly see, and you might want to do this, you might want to select them all and say conditional formatting. Give me some nice color scales. Oops, color scales right there. And that will highlight which ones are, and the green there, the dark green is going to be the one that really stands out because that's 2.47. So that tells me that this observation, which is the fifth observation corresponding to this point right here, is 2.47 standard deviations above the mean. So that means it's standing out there. Wow, that's uncommon. That's unlikely to see. And we usually say that plus or minus 1 standard deviation isn't of much interest. Your average, your normal. Plus or minus 1.5 standard deviations. Or what is it? How does he say here? You should consider an outcome quite normal if the standardized value is between negative 1.5 and plus 1.5. Now, there's no formal rule to say when an outcome becomes unusual, but you might start thinking a point is unusual when the standardized value is larger than 2.5 or much smaller than negative 2.5. But it depends on how much data you have. Now, there's another way you can do this that's just a little bit simpler, and we call it standard. I didn't even spell it right. Standardize. Okay, and you can say equals STAN, standardize, and we're going to standardize this number, comma, given the mean that is here. Oops, that wasn't the right one. Giving the mean that is here, comma, and the standard deviation that's here. Close parenthesis, enter. And because of the way I set up that formula, I can easily double-click there and copy it all the way down. And you will notice that they are the exact same numbers that we have in the column previous. So that's just two different ways of calculating z-score. One is to go through the trouble of calculating the standard deviation, calculating the mean, and then doing the calculation that you see down here, or just use the shortcut of standardize. And if we do the old conditional formatting there with the color scales, you'll see that they are identical. That's it.